Hello, my name is Christopher Pratt. I'm a statistics tutor at Broward Teaching Center. I will be looking at the Stats 2 Packet A to help you review some concepts for possibly your first test, other things along those lines. It's on the Broward Teaching Center website. Alright, here we go. Alright, so the first question defines so we're looking at probabilities of 2 dice rolls. So, question 1. Okay. So 2 dice rolls, and we're going to find the following events. A equals rolling 1 even, 1 even, and 1 odd. 1 odd. B equals the event of rolling a 2 and a 3. And C is rolling a total of a 7. Okay, this is A, B, and C. So when I look at these problems, they're confusing. Okay, so don't be scared if you don't get them. The first thing that I often do, and it's often useful in probability, is to write out the sample space. And as you note, I wrote a hint that said the same thing. It's often useful to write the sample space, and most probability problems, and in fact all of these, can be found just using the sample space. Okay, so let's write it out. Okay, so sample space. Sample space. Okay, so since there are 6 possibilities for each dice, there are 6 times 6 equals 36 possible 1 dice, 2 dice combinations. Okay? Now, some would say that there are really only 18 combinations. But in fact, and in most probability problems, order in this question matters because let's see. If your life depended upon getting a 1 first and then a 2 second, and you got a 2 first and a 1 second, even though you would say that there's the same exact dice roll, it really does matter. It would matter which number came up first. So, in that manner, I'll write out the sample space. So let's see. You have a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, and 1 and a 6. Okay? So all combinations with a 1 in it. Then you have a 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. Oops. Now that's all 3. 3 and 1. 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Okay. Just put some commas. Okay. So this is the sample space right there. Okay. So these are all possible combinations of all dice rolls that you can get with 2 dice. Okay. Now the first question, part A, asks you what's the probability of A. Okay? So the probability of rolling 1 even, sorry, One even, one odd. So you guys have the question. So that's whatever is there is the correct. Okay, so now we can look at the sample space and check, okay, which combinations of these, which pairs have one even and one odd? Okay, so this one has even odd, this one, this one, this one, this one, this one, this one, this one. This one, this one, this one. And you'll notice that every other pair has an odd, even combination, okay? And that equals, so that means that P of A, probability of A, equals 18 over 36, which equals 1/2. Okay? Now, alternatively, all right, you could have looked at an equal representation of the sample space. You could rewrite the sample space as all the possible combinations of even odd. So you could do even, even, you could two evens, even odd, odd odd, and odd even. And notice that this gives you the same answer if you do that. So just two different ways to do it. Whatever way you're comfortable with is fine. They're both equally correct. All right, so that's probably A. Okay, let's see. I'm going to keep these circled because I don't want to rewrite them. Okay, so the probability of B, rolling a 2 and a 3. Okay, so let's reference the sample space again. Okay, so which of these have a 2 and a 3 in them? Okay, not this one, not this one, not this one, none of those. Okay, none of this. Okay, so let's draw it in blue. So ones that have a 2 and a 3 are this one and this one. Okay. And do any of the other ones have a 2 and a 3? No. Those are the only two combinations. So the probability of B equals 2 over 36, which equals 1 over 18. Okay, which is exactly correct. Oops. Like a 2 and a 3. What? That's not one of them. Okay, yeah. So it's 1 over 18. Two of these have a combination of a 2 and a 3. That's exactly the correct answer. All right. Okay, so let's see. Probability of C. Okay, probability of C. I'll do this one in green. Okay, probably rolling a total of a 7. Okay, so let's see. Let's look at all the things, all the possible combinations that add up to 7. Okay, so what adds up to 7? A 1 and a 6. So obviously a 6 and a 1 add up to 7. So yeah, up to 7. Let's see, what else? 2 and a 5 and a 5 and a 2. 3 and a 4 and a 4 and a 3. And notice the off-diagonal entries of this little matrix-looking thing have all of the entries that add up to 7. Okay? So that equals 6 divided by 36 equals 1 over 6. All right. So, okay, so we have the probability C. And this is actually why people say lucky number 7, because you're more likely to get a combination of 2 dice equaling 7 than any other combination of 2 dice. And you'll notice that makes sense because this has 6 entries, and any other combination, like notice all of these equal 8. But there are only 5 of these. There are 6 of these, so obviously it has the greatest probability of happening, as we have shown. All right, let's see. Okay. Probability A and B. Okay. Okay, so we want the probability of A and B, which is A intersect B. Okay, so we want the probability of rolling one even and one odd, and the probability of rolling a 2 and a 3. Okay, so let's look at all evens and all odds. Okay, it's the black circles again. There are a lot of colors now, and you'll notice the only couples, the only pairs of numbers that are even and odd, nope, this one, but also 2 and a 3 are in fact 2 and 3. All right? So the probability A intersect B is just again 2 over 36, which equals 1 over 18. Okay? So it actually, the probability of just getting, the probability B actually equals the probability of A and B, interestingly enough. Okay, part E. Okay, so the probability of B and C. B and C. Okay, let's see. What's the probability of getting a 2 and a 3 and rolling a total of a 7? Okay, now I want you to look at all the sample space. Okay, and think to yourself, in how many ways can I get a 2 and a 3, both dice being one dice being a 2, one dice being a 3, and then adding them both up to be a 7? Okay, and you'll notice that is not possible. You can't get 2 dice, one being a 2, one being a 3, and then them also equaling a 7, because that doesn't make any sense. So the probability of B intersect C actually equals 0, big fat 0. Okay, so probabilities can be 0. A lot of people, maybe not a lot of people, but some people are scared of the thought that the probability being 0, they think their teacher's trying to trick them, but in fact, there sometimes is a 0 chance of that happening. Like, the chance of me getting a 15 on 2 dice rolls is also 0, but many people think that is immediately untrue, but with a little thought, it's also 0. Probability of, so part F now. Probability A and C. Let's see, the probability of rolling an even and an odd and a total of 7. Okay? So now we're going to look at all the things that total 7 and are even odd combinations. All right, so let's see. Only these 6 total 7, right? Okay, so 1 and 6. Okay, that's an even and odd. 2 and 5, even and odd. 3 and 4. All right, even and odd. 4 and 3, even odd. 5 and 2. Oh, and 6 and 1 as well. Yeah, okay. So, as it turns out, the probability of A and C is, in fact, the same thing as the probability of C. Which equals 6 over 36 equals 1/6. Just like before. All right. Okay. So, yeah. So many intersections actually equal just the probabilities of one or the other. Okay. So finally, we want the probability of not A, which is equivalent to, this notation may be new or not new, or may have never seen it, probably AC, or the complement of A, or some teachers write it as probability of A with a bar on top of it. All of these are equivalent logically, so don't be scared, they're all the same thing. Okay, so, and as you may or may not know, the probability of A complement equals the probability, or yeah, 1 minus the probability of A. Okay, and we've already found the probability of A equals 1/2. So it's 1 minus 1/2 equals 1/2. So what this is saying is the probability of not rolling an even and an odd. So obviously that's the probability of rolling both odd or both even, which, as you saw before when I wrote out the even, even, odd, odd, even, odd, odd, even, oops, half of them had even, odd combinations, but the other half has even, even, odd, odd combinations. And they're equally likely to happen. All right, so the probability of not A is 1/2. All right, and that concludes question 1.